Hey, back with some more Lewis dot structures here. We're gonna look at these structures now, but let's review. What do we look at? What was this? Remember the shape of this? Trigonal planar. Yep, all one plane. Find angles 120. All right. How about this? Got a lone pair, then three atoms connect to the central atom. See that triangle base pyramid. So it's pyramidal, okay? I think I got rid of the tetrahedrals that we looked at. So let's look at these three up here, okay? First, sulfur hexafluoride. Sulfur hexafluoride, that was the gas that we looked at. Remember, this gas makes your voice really deep. We looked at a couple videos when we were still in school. So sulfur hexafluoride. So let's look at the Lewis dot structure first. Sulfur hexafluoride. So sulfur has, hey, six valence electrons. We're gonna put one fluorine here, right? Some of you may have caught on that you can use a dash like this for 2 electrons if you'd like. That's fine. Fluorine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Now, what do we have to do now? Well, we have to separate these lone pairs, okay? We need to put 6 fluorines around the sulfur. We'll put one here. Put one here. We'll put one here. Put one here, okay? So if you need to separate lone pairs around the central atom, you're welcome to do that. Now there's 6 atoms around the central atom. That looks like garbage. So if we look at this, remember the shapes of molecules sheet I'm going to send you? If you look at this, it makes it pretty clear that the shape of this is octahedral. This is octahedral. Okay? All right, so if I want to show you a balloon model of this, how many balloons would I have? Yeah, there's no balloon for that central atom, so we'd have 6. What would it look like? Think about what it would look like. Here it is. Here is sulfur hexafluoride. It's kind of neat, isn't it? See, these 4 are in the same plane, and this fluorine here. Octahedral. 1, 2, 3, 4 planes. This is a square-based pyramid, and then a square-based pyramid on the bottom, so the bases are connected to each other. Octahedral. Notice how many balloons are coming out towards you. 1, 2. 2 going away. So we'll try to draw it to make it look like this, okay? Because this does not look good at all. All right? All right, here we go. Ready? Okay, sulfur, central atom. Okay, we have 2 balloons coming out. Put fluorine here. We're going to use the wedge, of course. All right. 2 balloons going in. Balloon on top, balloon on the bottom. Now that may not look like much yet. And then now we want to draw I forget the name of it, where the faces meet, that line. So we'll do this. What do you think? That looks pretty good, doesn't it? Does it kind of pop out at you? These fluorines are out here. Excuse me. So if you think about these fluorines here, these balloons. Fluorines, this balloon, fluorine. There's 2 balloons going into the board. Sulfur hexafluoride, okay? All right, not bad. So let's look at PCl3, phosphorus pentachloride. We have phosphorus has 5 valence electrons. So we're going to attach a chlorine to each of those. I'm sorry. Just do this real quickly now. You guys have caught on to this, I'm sure. 5 things connected around an essential atom. So this is called, if you look at that shapes molecule sheet, it's what is it? Trigonal bipyramidal. Pyramidal. I think that's how you spell pyramidal. That doesn't look right. So let's see what we can do with this. Let's bust one of these balloons. Let me get something sharp to bust with. Here's a toothpick. All right, ready? Let's bust this balloon. And now we have, that just scared my dog, Casey. Casey, it's all right. It's all right. Let's put these balloons together. The trigonal bipyramidal. So we have 5 balloons, 5 chlorines around that central atom, phosphorus. So now we have a shape. What do you think? So there's now 3 balloons in this plane, okay? Trigonal bipyramidal. So let's see if we can draw that. All right, here we go, phosphorus. Let's put a balloon coming out towards you, like that. A balloon going in here, and a balloon in this plane of the board. Chlorine here, and then let's draw those lines. 1, 2. What do you think? That wedge is not that great, is it, Casey? Huh? I should show you guys my dog. Hey, bear with me for a second. Excuse me. Casey. No, Casey, don't bite those balloons. Here's my dog, Casey. Casey, here. Hey, say hi. Sit. Good. Here she is. Plots. Hey, Casey, plots. Oh, someone just got home, so here she goes. All right, back to, you see my ugly mug here. Let me make sure figure this out. All right. Hey, let's look at sulfur tetrafluoride. So let's see what happens here. Sulfur. 1, 2, 3, 4, 5, 6. So we got, let's put a fluorine here. Fluorine here. Uh-oh. Okay, let's separate these. Hey, look what happens. There's still a lone pair there. So, what is that? So let's take this, pop one of these balloons, okay? And let's add a balloon. Hold on. Let's add a yellow balloon. That's a lone pair. Let's add a lone pair in there, and we'll see what the shape of this is. There's 5 things around that central atom, so it's basically trigonal bipyramidal, okay? But it's not. Its shape is trigonal bipyramidal. Its structure is something else. So this is what we have. So that's the lone pair here, okay? So if you look at this gotta use your imagination. You gotta use your imagination big time. Whoops, just came apart. We call this seesaw, and that's gonna be on your shape sheet I call it. It's 4 atoms connect to the central atom and 1 lone pair. It's gonna be called, it's called seesaw. And the way we draw that would be, let's do this. Let's put sulfur. Let's put the lone pair here, okay? Put a fluorine here. Fluorine here. Fluorine here. Fluorine here. And let's draw these things. That looks okay, huh? Yeah, so, all right. What do all these have in common, these 3 things? They all have what in common? Check this out. How many electrons around that central atom? Yeah, a lot. 12. 10. Is that 10? 1, 2, 3, 4, 5. Yeah. How about this? 10. 1, 2, 3, 4, 5, 6. They're over the octet. So let's make sure you understand what elements can go over the octet. If you look at your periodic table, the 3p area, so we have, it's phosphorus, sulfur, chlorine. These elements and the ones below can go over the octet. So this is the 3p, it's the third period, and these elements and below can go over the octet. They don't always, but can go over the octet. Just as this sulfur, phosphorus, and this sulfur, they're over the octet. Okay. Okay, the next video will be on drawing resonance structures. So you'll have some work with this. I'll send you the shapes of molecules sheet, and that is it.